Hello students, I am Sujnan Nayak and in this video we will be discussing certain topics which may be helpful in your preparation for physics examination. Over the years we have noticed some common mistakes that students do in their physics examination which can be easily avoided. We will discuss each section starting with our first section, force, work, power and energy. In section 1, let me tell you some common mistakes. The basic mistake that students do is in units of for mass and weight, especially the numericals which involves the meter scale, 1 meter or half meter scale. Usually, when mass is asked, students tend to write the answers in gram force or kilogram force, which is unit for weight rather than mass. This is one of the common mistakes the students do. So while solving numerical, make sure you read the question twice and also uh, exactly look into what they are asking. Okay, that's the first common mistake the students do. The second mistake, which is again the next most common, is the distance. Now, where should the distance be taken from? From the center of gravity or from the pivot? You should always remember in a meter scale example or half meter example, it should always be taken from the pivot. Next common mistake is suppose they ask you to find the net moment. So whenever net moment is asked, when the moment is asked, basically we should always mention whether the moment given or whether the moment which we found is clockwise or anti-clockwise. Students tend to miss out these common things and they lose mark. The next common mistake is the diagram of block and tackle. See students, uh, over the years I've seen that students lose their mark, especially when they do not make the arrow for the tension in block and tackle and also the arrow for the effort. So one thing that you can do is to go through the diagrams again, okay, as a part of your preparation. Section 2, light. In this section there are three chapters, okay. Now here the common mistake the students do is they tend to get confused between the factors affecting the different things. For example, there are many questions here. Factors affecting the refractive index of the medium, lateral displacement, angle of deviation, shift, critical angle. Now these factors are very important and they are generally asked in exam either for 2 marks, mostly for either for 2 marks or 3, mostly for 2 marks they are asked. Here the thing the students do is they get mixed up and they tend to make the silly mistake. For example, for critical angle they may write for refractive index and so on. Here you need to learn these factors carefully and also understand their proportionality, whether one increases the other increases directly proportional, if one increases the other decreases indirectly proportional. So you need to learn this properly and mention this relationship while writing the factors. So either you use the term proportionality or inversely proportional, or you may write, okay, if this increases the other also increases, if this decreases the other decreases. You need to mention these things. Just writing the statement won't help. For example if I say refractive index of a medium depends upon, you just write wavelength, you won't get the mark. You need to write the entire thing, how wavelength is related to refractive index of the medium. So one of the common thing you need to know. Okay, don't write just the heading. You need to mention the relation. So whenever factor question is asked, factors affecting, you need to mention. You need to remember this. The next thing is the prism diagram. See, these prism diagrams are very important. So is the lens diagram. I'll talk about. In prism diagram, the common mistake is, see, apart from one diagram, in all the diagrams we can find angles. So wherever angles you can find, especially by turning the ray by 90 degree or 180 degree, we can easily find the ray angles. You need to mention the angle, but at the same time you need to draw the normal which we tend to forget. So you need to draw the normals too, along with mentioning the angles in prism diagram. Okay, and it is not necessary. sometimes they give you a diagram in your examination paper. So it is not necessary the diagram should be of the same size. You can draw a fairly bigger size and tend to draw a prism in large size simply because you get more space for writing the angles, okay, in the prism. In the lens, we always encourage students to draw the entire lens, but suppose if they are drawing a line, but then they need to mention at the top regarding which kind of lens this is. And also you need to remember, if you forget to draw arrow marks here, you lose all the marks. So arrow mark is very important. So it's the tap on a object and that on the image that you find. Okay, so also learn the applications same for a particular diagram in the textbook. If you go through, for example, Selena, if you go through it, you'll find that after every diagram they have given you the application and where it is used. You need to learn that those two along with the nature and position of the image formed by the lens. Next is the wavelength. See, when the topic has been reduced this year, the portion has been reduced in the spectrum. You need to remember the common properties, okay, belonging to all the electromagnetic spectrum. The next thing you need to remember is the wavelength in both angstrom unit and nanometer. Please make sure you learn them into nothing difficult. Even if you know one, for example, angstrom, you just need to divide it by 10 and you will get it into nanometers. But you need to remember these things while doing the section number 2. Okay, section 3 is sound. Being a single chapter and a fairly important one, I'm expecting more number of questions from this chapter. Majority being application based question from the types of vibration like natural vibration, forced vibration, damp vibration, and resonance. In this chapter, common mistake is lack of understanding of these three types of vibrations. So I would request you to go through them properly, understand them, also understand the difference between them and various examples related to them. Okay. The diagrams also, for example, the displacement time graph of a damp vibration as well as the natural vibrations, which you need to know because this can also be asked in examination. Another silly mistake that students usually do is to unable when they are unable to understand which is the time of echo, so they tend to miss out that. So also solve simple numerical based on echo. Okay, the next is understanding the subjective nature, the other type of question, subjective nature of loudness, pitch, and the objective nature of intensity and frequency, and then factors affecting the loudness of the sound which you need to study. So this year we can expect a single section in the second part of the examination where, which is section B. We can expect a single question of 10 marks from one single chapter of sound itself. We can also expect more number of questions in the section 1 also. Okay, so this being one of the important chapters. The next section is section 4, electricity and magnetism. Now it consists of actually 3 chapters, but due to reduced syllabus we don't have one chapter, so we are left with current, electricity and household circuit. The most problem that students face here is as far as numericals are concerned. But before coming to that, let us discuss certain things. Ohm's law, factors affecting the Ohm's law, and the diagram for the Ohm's law, which is V versus I graph, and how to find resistance using this law. Also, students need to remember what's the unit for resistance, resistivity, and what's the difference between them, conductance and conductivity, difference between them as well as their units. Students tend to mix up these two things. Okay, so these are the common things we need to look into. The other wings, example of superconductors, we need to mention the temperature also. So you need to remember at least two superconductors with their temperatures in Kelvin. Next is the combination of resistors. One of the common mistakes that I find is students while finding the parallel, the combination of resistance in parallel, equivalent resistance in parallel, where the formula is 1 by R equals to 1 by R1 plus 1 by R2, which is an addition in inverse basically. Students tend to make silly mistakes. So I would request you to go through this numerical, at least practice some of the simple numericals. There won't be any numerical which involve more than 4 resistors. So it will be, these are fairly simple ones. So how to find the parallel and how to find the series resistance. So for example, if there's a division of current, we say it's a parallel connection, and if there's no division of current, we can consider it to be a series one. So what are the factors affecting internal resistance, equivalent resistance in series and equivalent resistance in parallel, how they affect the total current in the circuit. The next mistake is the unit of power and energy. For example, kilowatt hour, kilowatt get mixed up. Whereas kilowatt is the unit of power, whereas and kilowatt hour is the unit of energy. So whenever there are numericals, for example, they are asking the energy consumption at our homes. So always remember, if they are asking for domestic energy consumption, basically at home, or suppose even if in industry, always find the answer in kilowatt hour rather than in joule. Even though SI unit is joule, but whenever we are asking for energy consumption, okay, so we will say we'll always find the answer in kilowatt hour, okay. And then 1 kilowatt hour, the relation between 1 kilowatt hour into joule, always remember you can directly use it, okay. Then finding the cost of energy. For cost of energy, even if they are, suppose they just give you the power ratings and the time for which the appliance has been used, and find the cost, always find the answer in kilowatt hour multiplied by the cost per unit, which is 1 kilowatt hour, the commercial unit of energy, you need to remember. Another common thing which I want students to remember, which they find difficult, I suppose they should go through it also again and again. If they have any, they should get back to their teacher, which is EMF and terminal voltage. You need to understand the EMF. You need to understand how the formula gets converted to different or take different forms. Basically, it is a simple same formula which is written into different forms, which includes internal resistance, total resistance, terminal voltage, and current and EMF basically. So you need to find the difference between them. Solve basic and simple numerical involving terminal voltage and EMF. Apart from sound, even this chapter can expect to have at least one section of in section 2 where 10 marks will be dedicated to this section, and in section 1 fairly more number of more number of questions than we usually have, because one big chapter is been reduced, so naturally the marking from this section also increases more. That's it for section number 4. Next section is section 5, which is heat or calorimetry. Now in this section there are many things where students need to look carefully, especially the first topic I'll deal with is units. See students, um, even though the units that you're being given can maybe in degrees Celsius, they won't change the numerical value as far as for example specific heat of a particular substance, for example water has been given, it won't change the numerical value. But the common mistake the students do is when they write a final answer, they take degrees Celsius, which is wrong, because the final answer is expected to be in SI unit, which is Kelvin. That's the most common mistakes which I have been seeing students do again and again. So as far as numericals are concerned, the first thing the students need to understand whether all the, for example in the numericals regarding to mixtures, whether both the side left hand side and the right hand side, whether the units are in mass or kilogram, uh, degree Celsius or Kelvin, you need to make sure on both the side the units are in common. Units are common. For example, if it is mass in grams on left hand side, make sure the constants which are given to you, for example maybe specific heat capacity, they are also in grams, or convert them into grams. So if in kilogram, change the mass of the metals given into kilograms or vice versa. So make sure they have common units. This is a common mistake when students do. The other mistake is reading a graph. See children, there is a change of state, change of phase from solid to liquid, liquid to gas, and so on. So you need to go through this graph, especially for water, and understand it properly, and also understand why the heat of vapor in the graph you may see the latent heat of melting, specifically the latent heat for melting and the latent heat for boiling. The graph length is different. You need to go through this also, understand the information. So reading of graph is very important for calorimetry. Okay, and the next thing is to understand the difference between latent heat and specific latent heat, heat capacity and the specific heat capacity, and also learn the relation between them. Okay, another mistake is student tend to mix up between heat capacity and specific heat capacity, and also in their notation, because it's just C and one C with a capital C with a dash. So make sure you go through them again, and you understand them and do not get confused between them. The next chapter, the last section being radioactivity. See children, in chapter radioactivity, as most of the things are theory, and the mistakes the students make here is in the equation for alpha decay and beta decay. Students forget to write the products properly, and products with their mass number and atomic number. And you should also practice how to do this equation in reverse order, because question can also be asked not only okay a particular element emits alpha particle and so on, so you get y and so on, so then it further emits a particular particle. We need to also learn the numericals where it is the question has been given the other way around, means in the reverse order. So simple calculations are involved here, but students tend to make a mistake here also. So make sure you go through them, and also the asterisk sign which we use for excited state, especially when a particular element is going to emit a gamma ray. So go through these things properly for radioactivity. Okay, so these are the things you need to remember while preparing for your physics examination. Now, students, last part is what I want to discuss. See, we don't have a common blueprint for physics as such. Neither for any subject that okay, this chapter will have come from this marks and so on. But if you go by section wise, see if you look students, we have two parts of the paper, section 1A, part A, which has four questions, and which are compulsory, okay, and all the questions will be 2 marks. And then we have section B, in which there will be 6 questions given to you, out of which you need to write 4 sections. Okay, see right now we have 6 sections, so we can assume that every section will have 10-mark question in section B. So I can expect section 1 as 10 marks, section 2 as 10 marks, section 3 as 10 marks, 4 and so on. Okay. But again, if you ask me, as with over a period of time I have seen that if I want to rank the section according to the marking of weightage which can be expected this year, then students I will ask you to consider section 2, then section 3, then section 4, 5, 1 and 6. This may be the most probable order in which the weightages would be divided depending upon the content that it has. So this may be the most likely scenario in this examination. Apart from this, if you have any queries, you can certainly get in touch with our teachers at my tutorials, including me, and we can discuss those topics before examination and also. Thank you.